So the last thing we want to do is to look at the modeFrontier workflow that we're going to be using to implement CatBot in our automated experiment. And you can find a sample modeFrontier file in the included workflow folder. If you open that up, you're going to see a file that looks like this. If you look, this part of the workflow is exactly the same as before. That was our original workflow. And basically, there's inputs coming in. These are all the state change inputs. There's also a few inputs that define the floor offsets. And then there's the scheduler and the DOE being put into the Catia. And then objective coming out. In this case, we're counting the total number of braces being created. And then eventually being put to an exit node. And then this part is everything that we're adding to be able to work with CatBot. So a lot of this stuff is going to be set up already for you. You don't have to worry about it, but I'll run through it just to introduce you to some of the concepts. The first step is the DOS batch. If we open that up, you don't have to change any of these things. If we open up the script, this is basically the same thing as this batch file here. It's doing the same thing. If we go through it, basically what it says, the sleep function will put the whole modeFrontier on hold for 30 seconds. So that is oftentimes necessary if your model is really complex. modeFrontier will actually go on to the next test before the structural analysis is done, and that'll cause your model to start breaking. So if your model is breaking, you don't know why, try to increase this sleep number, which will force modeFrontier to basically wait for the structural test to finish. These will also be set up for you. You just want to make sure that all the things correlate to your setup on your computer. For instance, I'm running the workflow folder off of my C drive. You're going to be running off your E drive at school because we can't write to the C drive. So make sure that these are changed to E every time you see C here. And then this is basically how it's managing the output files, mostly this text file. So here you want to make sure that the same name is used for your text file. And the default is template, and I would just keep it at that. And then this also says, basically the second line will delete the template file that came before. It'll also execute CatBot that's in the workflow, so you want to make sure this path leads to where the CatBot exe is here. And typically, since we're putting this workflow folder into your E drive, that's going to be like that. And then this is saying basically overwrite the result, which is going to be the robot file. If you would like to save every robot file, you can also change this to a -C, but that typically takes up a lot of space, so we don't usually do that. And we'll put the robot file also into your workflow folder, and then this will copy the template file that's creating in the workflow folder into each individual test folder. So like before, when we would look through the folder structure to get the JPEGs, you're also going to be able to see every output file in that folder structure, and that's what copies it over. And then this exits. So like I said, you don't really have to worry about what's going on here. Just make sure that all these paths and file names are all consistent, or you're going to get trouble. So click OK. You can exit out of this. The next point is a transfer, and this basically moves that text file from this node to the analysis node. And here again, you don't have to change anything. Just make sure that this file name matches with the file name that you output in the previous node. I would just keep a template. And then this output template will basically take the text file, again, make sure that all of these are the same, and then it will search that text file for specific cues to be able to get your objectives. So how that works is you input this text file and you set up markers. And once modeFrontier hits these markers, it's able to get this text out. So for the test case, you don't necessarily need to know how this works. We have it set up to test 3 objectives, which is the total number of bars failed, the maximum X displacement of all the nodes and the maximum Y displacement of all nodes. If you want to just start out testing for these three, you don't have to change anything in this node. If you want to pull out other values from the text file, we can get into that later. But basically, to do that, you set up these queues where it'll look for the word displacement, look for 5 lines down, and take the second value, and it's semicolon delineated. You can see here, here's the Y, the X displacement value, here's the Y, and then if we double click bar failure, it's all the way at the bottom. So we can set up these custom queues, but we won't get into that for now. And all of these basically correspond to our output nodes here. So if you want another output, you add an output node, it'll come up here, and then you set your queues. We can do another tutorial later just for that specifically. Okay, so we press OK, we exit out of that, and then we have set up our outputs, same as before, linked into our objective nodes. I'm just going to show you the Catia file really quickly. It's the same as before. We have our state change inputs and a few inputs down here. We also have objective that has nothing to do with structure coming out here. You won't see your structural outputs here as before because they're going to be taken care of by this node. You'll just see the ones that aren't structural. And then importantly in here, we want to set up the Catia document. This time we want to check the box that says keep alive, make sure that's checked. That's going to make sure that the model stays open while the structural analysis is running. And then as always, we want to make sure that it's outputting the JPEG file. And then we can click out of that and we should be ready to go if you hit run. And keep that name. And we'll run it. And here, if we go into the design, we can see kind of the additional processes that are happening. You'll see this is the Catia 3 node is running as usual. It'll open up our Catia file and run the script. Now it's finished, and now it's moving on to the DOS batch. This is the thing that launches CatBot. So right now, CatBot is running and opening up Robot in the background. And this will take, for this model, about a minute. And it's basically doing the same thing as before. It's listing all the geometry that we put into those special folders. It's opening up Robot, sending that geometry to Robot, and creating a new structural model from that geometry, analyzing it, creating the robot model, and creating the text file. And while that's working, we can see in here, basically, we're going to see a new CatBot file, or a robot file being created as soon as it's done, so we'll see it update. We're also going to see the template text file update here. And those template files are also being added to each test folder within the experiment. So you see here the new template file was created, 11.14, and as soon as it's done, we also saw a new robot file being created about 2 minutes ago. So now as the design's done, you can see a lot more has happened. It ran the DOS batch, it exited the DOS batch, it created this file template in this folder for each experiment. It transferred the file, it read the file, and got the outputs, and then completed the design. Now it's on to the next one, and so on and so forth. So everything's running as expected. We can go into these folders again and check our designs. Now, so far, this is kind of as usual. You can find your design, except this time it's added a folder for each new node. So before we only had Catia 3, we had the process files, including this JPEG. Now we also have the DOS batch, output template, and transfer file nodes. Most of these you don't have to look into. In the DOS batch, in the process, there will be this template file. So if you want to look at your results for each test, you can do that. Because we hit overwrite, it won't save a new robot file for each one. We can always go back into Catia, recreate the file according to the inputs, and then run the one-time CatBot batch file to get the robot file and analyze it. And that's a better way to do it because you won't be eating up all the hard drive space. You can see here for a simple model, the robot file is already 2 megs. So if you're running thousands of tests, it's best not to save those files and just create them when you need them. So I'm going to let this experiment run for a few more tests, and then we can analyze some of the results when we come back.